Circular motion. See, all important concepts, all important formulae will be discussed here. You need to expect only the same or exactly similar questions. Okay, you can see by watching this video you will be able to solve all questions from circular motion. Okay, see, when a body is moving in a circular path, the velocity of the body at any point on the circle is directed along the tangent to the circle at that point. Now, what is a tangent? See, if you want to draw the tangent at any point on the circle, draw the radius at that point. How do you draw the radius? You have to simply join that point to the center of the circle. That will be the radius at that point. If you draw perpendicular to the radius, that will be the tangent to the circle at that point. So, when a body is moving in a circle, see, the velocity at this point is directed along the tangent at that point, and velocity at this point is directed along the tangent at that point. Okay, tangent to the circle at any point is the perpendicular to the radius at that point. Okay, so for a body to move in a circular path, the direction of the velocity must be changing continuously. Okay, so the velocity cannot be constant because the direction must be changing. If the body is moving with a constant speed, means the magnitude of velocity is constant but the direction is varying, then the motion is said to be uniform circular motion. Motion of a body in a circular path with a constant speed. Okay, it's called a uniform circular motion. In uniform circular motion, the body experiences change in linear velocity only because of the change in the direction of linear velocity, because there is no change in the magnitude of linear velocity. Okay, now see, when a body moves from A to B, it describes an angle delta theta. That delta theta is called angular displacement. It is a vector, and that vector is directed along the axis of rotation. So, when the body is moving like this, the axis is like this. Okay, a straight line passing through the center and normal to the plane of the circle. Okay, so the delta theta angular displacement is a vector directed along the axis, so it's called an axial vector. If it is directed along the axis, it can be along the axis outwards or it can be along the axis inwards. How do we find that? We have to use the right hand rule. Okay, stretch the fingers of the right hand perpendicular to the thumb. Okay, then curl the fingers along the direction of motion of the body. Okay, curl the fingers like this, then the thumb points along the direction of the axial vector. Okay, so delta theta is directed along the outward normal to the plane of the boards. Okay, now see, as the body moves from A to B in a short interval of time delta t, during that interval the displacement is this straight line AB, linear displacement delta r, and the angular displacement is delta theta. It is directed along the axis outwards. Okay, now see, this omega means the angular displacement in unit time. In delta t time it describes an angle delta theta, so in unit time it describes delta theta by delta t. It is also an axial vector. Okay, now the linear velocity v equals omega cross r, where omega is the angular velocity and r is the position vector of the particle with respect to the center of the circle. Okay, v is the linear velocity, angular velocity, position vector. Okay, the see, differential of v with respect to t means dv by dt. We have to differentiate this product, so you will have to use the product rule. Okay, so it will be omega cross dr by dt plus d omega by dt cross r. R being the position vector, dr by dt will be the velocity. Okay, linear velocity, dr by dt, linear velocity. Omega is the angular velocity, so d omega by dt is the angular acceleration. It's represented by alpha. So d omega by dt equal to alpha. Okay, so dv by dt, v being the linear velocity, dv by dt is called linear acceleration. Okay, so linear acceleration equals omega cross v plus alpha cross r. See, only similar quantities can be added. Means a velocity can be added with another velocity. A velocity can be subtracted from another velocity. So only similar quantities can be added and subtracted. If you add two velocities, then you will get another velocity. If you add two forces, you will get another force. Okay, so linear acceleration is the sum of this and this. Okay, so if these two quantities are added, these two must be similar quantities. By adding these two, we will get linear acceleration. See, if the sum of these two components gives an linear acceleration, then each of these must be linear acceleration. So this is one component of linear acceleration. This is another component of linear acceleration. This is directed along the radius, so it's called a radial acceleration or the centripetal acceleration. This is directed along the tangents, it's called tangential acceleration. Okay, this is due to the change in the magnitude of velocity, tangential acceleration. So there will be tangential acceleration only if the magnitude of the velocity changes with the time. This radial acceleration is due to the change in the direction of linear velocity. Okay, whenever a body is moving in a circular path, the direction of the velocity must be changing. So the body must be experiencing radial acceleration. Without radial acceleration, no body can move in a circle. So the linear acceleration has two components. One is along the radius and the other is along the tangents. Radial acceleration will be experienced by a body whenever it is moving in a circular path. But tangential acceleration will be there only if the magnitude of velocity changes with the time. Okay, so this is the radial acceleration. Tangential acceleration is perpendicular to it. So the resultant linear acceleration will be the vector sum of these two. This is the radial acceleration, this is the tangential acceleration, and this is the resultant linear acceleration. As these two components are perpendicular to each other, resultant acceleration will be A equal to under root AR square plus AT square. Okay, now see, radial acceleration AR equals omega cross V. Omega and V are perpendicular. So omega cross V will be omega V sine 90. So it is omega V only. Okay, so in scalar form, radial acceleration is omega V. Okay, this V can be replaced by omega R. So it will be omega into omega R means omega square R. Or this omega can be replaced by V by R. So V by R into V will be V square by R. Okay, different forms of the radial acceleration. Okay, now this radial acceleration, as I have told you earlier, it is due to the change in the direction of linear velocity. Okay, so whenever a body is moving in a circular path, the direction of its velocity must be changing. So it must be experiencing radial acceleration. So there must be a force due to the radial acceleration. It will be directed along the radius towards the center. That is called a radial force or centripetal force. Okay, then the expression for centripetal force is mass into centripetal acceleration. Means mv square by r, or it is m omega square r, or it is omega mv. Okay, so in uniform circular motion, means motion in a circular path with constant speed, only the direction of linear velocity is changing. Magnitude of linear velocity is constant. Okay, so in such a circular motion or in uniform circular motion, speed is constant. Okay, direction of velocity changes. Okay, linear acceleration is not equal to 0. It experiences a change in linear velocity. Okay, radial acceleration not equal to 0 because it is due to the change in the direction of velocity. But tangential acceleration is 0 because it is due to the change in the magnitude of linear velocity. Magnitude is not changing in uniform circular motion. So tangential acceleration is 0. Now this tangential acceleration, actually see A with the suffix T, this is actually alpha cross R. This alpha and R are perpendicular to each other. So actually A with the suffix T in scalar form, it is alpha R. In uniform circular motion, if AT equal to 0, then alpha must be equal to 0. Alpha 0 means angular acceleration is 0, means angular velocity is constant. So in uniform circular motion, omega is constant. Okay, alpha equal to 0, AT equal to 0. Okay, now see, this linear acceleration A equal to radial components plus tangential components. In uniform circular motion, there is no tangential components. Okay, so the linear acceleration has only the radial component. Okay, so it is given by A equal to A with the suffix R in uniform circular motion. See, in non-uniform circular motion, a body is moving in a circular path with varying speeds. So not only the direction of linear velocity, but also the magnitude will be changing with the time. Okay, so it moves with variable speed, both the magnitude and direction of linear velocity change with time. Okay, so radial acceleration is not equal to 0 in any circular motion. Okay, in all circular motion or whenever a body is moving in a circular path, there must be radial acceleration. But tangential acceleration will be there only when the magnitude of velocity changes. Here the magnitude also changes, so it experiences tangential acceleration also. Means AT not equal to 0. If AT not equal to 0, then alpha not equal to 0. There is angular acceleration. So the angular velocity omega is not constant. Omega varies, direction of linear velocity varies, magnitude of linear velocity varies. Okay. Now see circular motion in vertical plane. See the most important thing. Please listen. The tension in a string will be acting on all the bodies to which the string is attached. The tension in the string will be acting on a body along the string and away from that body. Okay, now see a bob means a small sphere is being suspended from a rigid support by means of a string. Okay, so the tension in the string will be acting on this bob, B-O-B, bob. That tension is along the string and away from the body. When the body is at the lowest point, so tension will be away from the body along the string. Okay, string is like this. So the tension must be like this or T max. See, actually the tension in the string is varying. It will be maximum when the body is at the lowest point of the circle. So it is directed upwards, T max. Weight is always downwards. Here the body is moving in a circle. Whenever a body is moving in a circle, there must be a force towards the center. Here there are two forces, one towards the center T max and the other away from the center mg. Resultant force must be towards the center. What is that resultant force? T max minus mg. That provides the centripetal force. T max minus mg equal to m. The velocity here is v1. So m v1 square by L. From that we will get T max equal to m v1 square by L plus mg. Okay, when the body is at the highest point, tension is minimum. That will be along the string and away from the body. Away from the body means it must be downwards. Weight is always downwards. So resultant force towards the center will be T minimum plus mg. That provides the centripetal force. The velocity here is v2. So T minimum plus mg mv2 square by L. So T minimum will be mv2 square by L minus mg. Okay, T minimum mv2 square by L minus mg. As the body moves from the lowest point to the highest point, its velocity changes from v1 to v2. See, as it is moving in a vertical circle, so when it moves from here to here, height increases. So there will be an increase in gravitational potential energy. So there must be a corresponding decrease in kinetic energy. By the energy conservation principle, the decrease in kinetic energy must be equal to increase in potential energy. Half mv1 square minus half mv2 square equals mgh. What is h? This much is L and this much is also L. So the height will be 2L. So half m v1 square minus half m v2 square equal to mg into 2L. From that, you will get v1 square minus v2 square equal to 4gl. This is unconditional. This is always true because it is based on the law of conservation of energy. Okay, now see, for the body to be maintained in a vertical circle, there is a minimum velocity that must be given to the body at the lowest points. That minimum velocity is root 5gl. Okay, here v1 equal to root 5gl. That is the minimum velocity to be given to the body at the lowest point to complete the vertical circle. If we give a velocity that is less than root 5gl at the lowest point, it will go like this and returns. If the velocity is slightly increased, it will go to a little bit higher and then returns. If the velocity given at the lowest point is root 5gl or more, it can be anything more than root 5gl or equal to root 5gl, then only it will complete the vertical circle. Okay. If the velocity given at the lowest point is root 5gl, then at the highest point velocity will be root gl. That case is called a critical case. In that case, tension at the lowest point will be 6 mg and tension at the highest point will be 0. If the velocity at the lowest point is more than root 5gl, then the velocity at the highest point will be more than root gl. Tension at the highest point will be more than 0. Tension at the lowest point will be more than 6 mg. But the difference, maximum tension minus tension, minimum tension will be 6 mg always. See, T max minus T minimum equal to 6 mg. This is also unconditional. See, if the body is moving in a circular path, I tell you, the velocity can be anything greater than or equal to root 5gl at the lowest points. Correspondingly, the velocity at the highest point can be anything greater than or equal to root gl. But the difference, T max minus T minimum, is unconditional. It is always 6 mg. Okay. Now see, when the string is horizontal, if the body starts with the root 5gl from the lowest point, at the highest point root gl, and the velocity of the body when the string is horizontal, that will be root 3gl. Okay. Now consider a vehicle moving on a concave bridge of radius of curvature capital R. See, when the car or any vehicle, when it is at the lowest point of the bridge, see, it is moving in a circle, so there must be an unbalanced force towards the center. Here the center of the circle is, okay, see, above this concave side. Okay. So the resultant force must be towards the center. What are the forces acting on it? Normal reaction exerted by the bridge. Weight. Resultant force must be towards the center. Means the resultant force will be N minus mg, and that provides the centripetal force. So N minus mg equal to mv square by R. That is the resultant force towards the center. So N, normal reaction exerted by the bridge on the vehicle, that will be equal to mg plus mv square by R. This is the reaction exerted by the bridge on the vehicle. Then what is the force with which the vehicle presses on the bridge? See, when the vehicle presses on the bridge with a force, an equal reaction will be provided by the bridge. So if this is the reaction, this much is the force exerted by the vehicle on the roads. Okay. So the vehicle presses on the bridge with this much force. M is the mass of the vehicle and V is the speed with which it moves, and R is the radius of the concave bridge. Now if the bridge is is convex instead of concave, like this, at the highest points. Okay, see, radius is capital R. What are the forces acting on it? Normal reaction upwards and weight downwards. Okay. Now the resultant force must be towards the center. What is the resultant force towards the center? Force towards the center minus force away from the center. That is mg minus n. That provides the centripetal force mv square by R. So the normal reaction will be mg minus mv square by R. Okay. Now see, what is the maximum speeds with which the vehicle can cross the bridge? See, the vehicle should not lose its contact with the bridge. See, normal reaction will be acting on the vehicle as long as it is in contact with the bridge. For safe crossing, it should not lose contact with the bridge. Means it should experience a normal reaction. Means the normal reaction should be greater than or equal to 0. Okay, so the condition is normal reaction should be greater than or equal to 0. Okay, or let us say this mg minus mv square divided by r should be greater than or equal to 0. Okay, so mg should be greater than or equal to mv square divided by r. Okay, and see, this m and this m can be cancelled. So v should be less than or equal to root gr. Okay, for safe crossing. So when the vehicle crosses this bridge, the speed of the vehicle must be smaller than or equal to root gr, or the maximum speed with which the vehicle can cross this bridge is root gr. Now see, motion of a vehicle on a level circular roads. Okay, so as the vehicle is taking a turn, it is actually moving in a circular path. So there must be a force directed towards the center. Okay, that provides the centripetal force. Here the centripetal force is being provided by the friction. Okay, now see, what are the road is horizontal. So the weight will be acting downwards, normal reaction upwards. The body is in equilibrium along this direction. Okay, it won't be moving like this. So the force acting upwards must be equal to the force acting downwards. So N equal to mg. The maximum friction F max equal to mu into normal reaction, or F max equal to mu mg. Okay, that F max will be, or friction will be acting towards the center to provide the centripetal force. Okay, now see, if the vehicle is taking this turn with a speed v, okay, then the required centripetal force is mv square by r. mv square by r. That must be less than or equal to the friction. Okay, maximum friction. So mv square by r less than or equal to f max, or mv square by r less than or equal to the value of f max is mu mg. Okay, m and m can be cancelled, so v less than or equal to mu gr. V can be either less than or equal to, means it cannot be greater than this. So the maximum value with which the vehicle can take the turn is root mu gr. See, when the radius of curvature is very large, means see, like this, then the radius is very long. Okay, and if there is sufficient friction, we can take the turn with a moderate speeds. But in sharp turnings, suppose consider a turning like this, the radius is very small, and if there is raining, the coefficient of friction will drastically become low. So the safe speed with which we can take the turn will be much smaller. Okay, we cannot take the turn with a moderate speed. If we depend solely on the frictional force to provide the centripetal force, in such cases or in sharp turnings, okay, we will have to find out another source to provide the necessary centripetal force. That is the component of normal reaction. Okay, component of normal reaction. Okay, now see, the outer edge, not the upper edge. Outer edge of the road will be raised with respect to the inner edge by a small angle, and that process is called banking. Angle of banking. Suppose, see, this is the bed of the roads. Okay, and see, it is like this. Okay, like this. I am standing inside the circle. Okay, this is the road. Okay, so this is the inner edge and this is the outer edge. So the road will be like this. Means outer edge is inclined with respect to the inner edge through a small angle. It's called banking. Okay, this is the case. Now normal reaction will be normal to the plane of the roads. N, it can be resolved into two components, n sin theta to provide the centripetal force and n cos theta to balance the weights. Okay, so mv square by r equal to n sin theta and mg equal to n cos theta. If we divide these two, it will be v square by rg, that is equal to tan theta. So the speed with which the vehicle can take the turn, v equal to root of rg tan theta, this is called the critical speeds. Here we are not at all making use of the frictional force. So there will not be any wear and tear for the tires of the vehicle. Okay, this speed is called critical speeds. Now see, when a vehicle takes a turn on a banked road with a critical speed, it is not making use of the frictional force. Okay, so wear and tear of the tires will be reduced. Okay, but if we want to take the turn with the maximum possible speed on a banked roads, then what is that maximum possible speed? Okay, now when we find the maximum possible speed, see, in addition to this normal reaction, we will take or we will consider the friction also. Friction will be acting like this. Okay, frictional force down the inclined plane. Okay, friction like this, F. It can be resolved into two components, F cos theta and F sin theta. Now the centripetal force is provided by N sin theta plus F cos theta. F is the friction and F equal to mu into normal reaction. Okay, F equal to mu into normal reaction. Okay, and from here we will get V max equal to. Now see, when you divide these two, you will get see n sin theta plus mu n cos theta divided by n cos theta plus mu n sin theta. In the numerator there are two terms, in the denominator also there are two terms. So totally 4 terms. Divide all the terms by n cos theta. If you divide 1, 2, 3, 4 all the terms by n cos theta, you will get this results. Okay, so the maximum speed with which the vehicle can take a turn under root rg mu plus tan theta divided by 1 minus mu tan theta. Theta is the angle of banking and mu is the coefficient of friction. Okay, now see, if there is no banking, theta equal to 0. Okay, tan theta equal to 0. Then what would be the maximum speeds? Tan theta 0, so this term will be 0, this term will be 0, and within the bracket only mu remains. So the maximum speed will be mu rg. See what we have got in the first case. Okay, now if there is banging but there is no friction, means mu equal to 0. When mu equal to 0, this term numerator will become tan theta, denominator will become 1. So it will be rg tan theta. See what we have got in the second case. Okay, v equal to rg tan theta, right? Now see, motion of a cyclist on a level road. When a cyclist takes a turn on a level road, he or she will have to lean inwards by a certain angle. What is that angle? Okay, now suppose the cyclist turn inwards by an angle, say theta. Okay, so this is the normal reaction acting on the cyclists. That normal reaction can be resolved into two components, n sin theta, which provides the centripetal force, and this is n cos theta, and that balances the weights. Okay, mg. Okay, so n sin theta provides the centripetal force mv square by r. N cos theta balances the weights. If you divide these two, tan theta will be equal to v square over rg. Okay, tan theta equal to v square by rg. So if the cyclist takes a turn of radius of curvature capital R with a speed say v, then she or he will have to lean inwards by an angle theta such that tan theta equal to v square by rg. Suppose cyclist takes a turn by say 18 km per hour. 18 km per hour means 5 meter per second. So this will be 5 square 25. And suppose the radius of the circular path is 2.5 meter. Okay, it's a sharp turning. Okay, so this will be 2.5 into 10, 25. And in the numerator 5 square 25. So tan theta will be 1 and theta will be 45. Means she or he will have to lean inwards by 45 degree in order to take a turn of radius of curvature 2.5 meter with a speed 5 meter per second or 18 kilometer per hour. Okay. Now see motion of a vehicle in a circular path on the inner surface of a cylinder. Okay, you might have seen in circus and all. Okay, here see the vehicle presses on the vertical wall with a force. An equal reaction will be exerted by the wall on the vehicle. That reaction is represented by capital N and it stands for normal reaction. That normal reaction is the force acting towards the center. So it provides the centripetal force. So N equal to mv square by r. This one, N equal to mv square by r. Okay. So that is the force exerted by the vehicle on the vertical wall of the cylinder. So equal reaction will be provided by the wall and that is used as the centripetal force. Okay, now weight will be acting down. Frictional force supports this weights. Okay, there is no motion along this direction. So the frictional force acting upwards will be static friction because it is the friction acting on a body at rest because along this direction the body is at rest. Okay, now F max equal to mu into normal reaction. Okay, now see the frictional force, static friction, it is a self-adjusting force that is acting upwards must be greater than or equal to the weights. So F max greater than or equal to mg. F max is mu into normal reaction. Mu, normal reaction is mv square by r, that must be greater than or equal to mg. So V, this m and m can be cancelled. This r taken to the right, so it becomes rg. Mu taken to the right becomes rg by mu. So V must be greater than or equal to under root rg by mu. V can be either greater than or equal to this value. Means it cannot be less than. Or this is the minimum value. See, there is a minimum speed with which the vehicle can take the turn like this on the inner surface of a vertical cylinder. When the speed is below that value, it will slip down. When the speed is more than that value, it will have a tendency to move up, right? Now see the motion of a particle on the inner surface of a smooth, inverted right circular cone. Okay, see here the body is moving in a circular path like this. Okay, moving in a horizontal circle, right? Moving in a horizontal circle like this over the inner surface of this inverted cone. See, when the speed increases, it will have a tendency to move up. When the speed decreases, it will have a tendency to slip down. See, when the velocity decreases, it will have a tendency to slip down or to reduce the heights. When velocity decreases, height decreases. See, when its velocity increases, it will have a tendency to slip up, to move up. Means when the velocity increases, height increases. So there is a particular value of velocity to revolve at a particular height. When the velocity increases, height increases. When the velocity decreases, height decreases. So in the expression for velocity, height must be in the numerator. Then only velocity will increase when height increases. Velocity will decrease when height decreases only if the height comes in the numerator for the expression, in the expression for the speed of the particle. Okay, now see, normal reaction will be acting like this, N. It can be resolved into two components. N cos theta provides the centripetal force and N sin theta balances the weights. Okay, now see, N mg equals N sin theta mv square by r. R is the radius of the circular path in which the particle is moving. Okay, divide these two, we will get rg by v square equal to tan theta. Okay, now consider this right triangle. This is theta. Tan theta will be r by h. So tan theta replaced by r by h. Now see this r and this r can be cancelled. Okay, so v square will be gh and v will be root gh. Root gh means it is actually root gh by 1. In the denominator, 1 only. Okay, so all the factors are in the numerator. Okay, so V equal to root GH. When H is more, V will be more. When H is less, V will be less. Okay, this is the speed with which the particle can revolve in a horizontal circle at a height h above the vertex of the inverted chord. Okay, now see, a small particle is being suspended from a rigid support by means of a light, inextensible and perfectly flexible string. See, in physics, when we say string, it is massless actually. It is inextensible and it is perfectly flexible. When we say string, that word includes all these. It is inextensible, it is massless, it is perfectly flexible. Okay, anyway, this body, small particle is being suspended by means of a string from a rigid support. Now that particle is made to revolve in a horizontal circle. Okay, what are the forces acting on it? As I have told you earlier, tension in a string will be acting on all the bodies to which the string is attached, and the tension is along the string and away from the body. Okay, see, just suppose this is a pulley. Okay, and here there is a block, here there is another block. Okay, here there is a third block, and this is A, this is B, and this is C. Okay, now consider this string, the tension in this string. See, the tension in this string will be acting on the block B as well as on the block C, because that string is connected to both B and C, and the tension is along the string and away from the body. So the tension will be acting on B away from B. The same tension in the same string will be acting on C away from C. Away from C. See, first of all, a string can only pull a body. No string can push a body. Okay, so this string will pull the upper block B downwards, and the same string will pull the lower block C upwards. Okay, now see, in this case, the tension in the string will be acting on the block, on this small particle along the string and away from the particle, means like this. That string makes an angle theta with vertical. Tension in the string can be resolved into two components. T cos theta balances the weights, and T sin theta provides the centripetal force. Okay, so centripetal force, usually we write mv square by r. Okay, I have given one more form, that is m r omega square. It is provided by T sin theta and mg is balanced by T cos theta. Divide these two. R omega square by g equal to tan theta. See, consider this triangle, this triangle. Okay, this is the opposite side and this is the adjacent sides. So tan theta will be r by h. Okay, now this r and this r can be cancelled. So omega square will be g by h and omega will be root g by h. Period of revolution, t equal to 2 pi by omega. So it will be 2 pi root of h by g. Okay, now from this triangle again, okay, h is equal to L cos theta. H equal to L cos theta. So we will get another expression for the time period, that is 2 pi under root L cos theta by g. Okay, see, I have discussed all important things in this chapter in circular motion. See, if you find any question, any neat question, the concept or the formula will be in this video. Okay, thank you.